Well, welcome to lesson 2 of Unit 2 on linear equations. And we're going to go one step further with this lesson. We're going to learn to solve equations using multiplication and division. So let's review a little bit of what we learned in our last lesson. Our inverse operations. Inverse operations are operations that undo each other. And we learned in our last lesson that addition and subtraction were inverse operations. And in this lesson, we're going to focus on multiplication and division, or inverse operations. So when you're solving equations, if you see something using addition, to undo that, you are going to use subtraction. If you're solving an equation that has a subtraction in it, you want to use addition. If you have an equation that has multiplication, you're going to use division. And if it has division, you want to use multiplication. So we're using all of our inverse operations to solve equations. So what are equality properties? We learned in our last video about the addition and subtraction properties with the balance scale. And basically it said the same value can be added or subtracted from both sides of an equation, and the new equation is equivalent to the original. For example, if we start with a equal to b, then we can add c to both sides and it's still true. Likewise, if we start with the same equation, a equal b, a minus c will equal b minus c. Well, in this lesson, we will be extending that to multiplication and division properties. And that says that if both sides of an equation can be multiplied or divided by the same non-zero value, this has to be a non-zero value because we cannot divide by 0, then the new equation is equivalent to the original. For example, if a is equal to b, we can divide both sides, multiply both sides by c and get an equivalent statement where AC is equal to BC. Likewise, if A is equal to B, we can divide both sides by C and get A divided by C equals B divided by C. And remember that C cannot be 0. So, the amazing division property. Did you know that there's a definition of division? Just like we define subtraction in terms of addition, of adding the opposite, division is actually just multiplying by the reciprocal. So that means we get to choose whether or not we divide or multiply by the reciprocal. So the division, if you take A divided by B, the same thing, it means the same thing to take A multiplied by the reciprocal of the thing you're dividing by. So you'll be using that a lot to solve equations. So here we're going to use some inverse operations and equality properties to solve some equations. So if we start with example 1a, it says solve x divided by 7 equals 8 and check the solution. So you want to think about that as x divided by 7. So the opposite of being divided by 7 is to multiply by 7. So you multiply by what you're dividing by on both sides. Now the 7's will then cancel, right? So you should recognize that these 7's will now go away. 7 divided by 7 is 1. These become 1's and they just drop out. And so we just have x on the left, and 8 times 7 is 56. Well, our directions say we have to check the solution. So we're going to plug in 56 for the variable x in our original equation. And 56 divided by 56 divided by 7. And we want to check to see if that's equal to 8. And it is. 8 is equal to 8, so it checks. The next one, we have a fraction. We have negative 3 is equal to 3 halves x. So 3 halves is being multiplied by x, so we can choose whether we divide by 3 halves or multiply by the reciprocal. Well, multiplying by the reciprocal is always going to be easier, so let's go ahead and multiply both sides by the reciprocal of 3 halves is 2/3. And then you should be able to see that this 2 and this 2 cancel out, this 3 and this 3 cancel out, and we're only left with x on one side. So we have x is equal to, and our negative 3 we can put over 1, right? We can take that negative 3 and put it over 1. And then the 3's will cancel there. So this 3 will cancel with this 3, but keep that negative sign right there. Don't forget that negative sign. That's a common mistake. So we have a negative 1 times 2 is negative 2, and that's equal to x. Well, again, we need to check our work, so we're going to plug in negative 2 right here for x and see if that works. We have negative 3 equals 3 halves times negative 2 instead of x, and these 2's cancel again. So this 2 cancels with this 2, but we are left with a negative 1. So a negative 1 times 3 is negative 3, and that checks again. So it is a valid solution. Here are a couple more examples. 12x equals 132. X is being multiplied by 12, so the inverse operation is to divide by 12. Remember, we have to do the same operation to both sides. So our 12s cancel. 12 divided by 12 is 1, and we're left with x. 132 divided by 12 is 11. And then our check. Is 12 times 11 equal to 132? Well, yes, it is. If you check on a calculator, you'll get the same answer. Letter B, minus 8x equals 60. Well, here x is being multiplied by negative 8, so we want to do the opposite and divide by negative 8. That will allow our 8's to cancel, and our negatives will also cancel. A negative divided by a negative is a positive. So we get x is equal to 60 over negative 8, which is negative 7 and 4/8, which is negative 7.5. And then we can go ahead and check our work, plug that back into our original equation. 8 multiplied by negative 7.5, negative 8 multiplied by negative 7.5. I wrote negative 7.5 back as 60 over negative 8, and the 8's will cancel, and we get positive 60. So that one checks as well. And our last slide, I think this is our last slide, we have a fraction again. We have one more slide after this. 4/7 x equal to 9/14. That's our original problem. Again, we're going to multiply by the reciprocal on both sides. So 4/7 x equals 9/14. We want to multiply by 7/4 on both sides. And then the 7 and the 14 can cancel. I like to do my canceling in the beginning so that I keep the numbers small. And this 7 and this 7 cancel, these 4's cancel, and we're just left with x down here. And now we can multiply across. We have 9 times 1 is 9, and 2 times 4 is 8, so we get 9 over 8. And then if you want to write that as an as a mixed number, that would be the same as x equals 1 and 1/8, right? That's in simplified form. And our last problem, our word problem, find the width of a rectangular rug if the area is 44 square feet and the length is 8 feet. Well, we know the formula for the area of a rectangle is length times width, and we know that the area is 44 square feet, so let's go ahead and plug that in. Area is 44. That's going to go right here. And we know the length, this one is 8 feet, right? So we're going to plug that in for the length, and we'll go ahead and solve that then. So instead of A, we're going to put in 44. Instead of L, we put in 8. And 8 is being multiplied by W, so we want to undo that by dividing by 8. And then 44 divided by 8 is 5.5, so that we find that the width is 5.5 feet. That'll do it for this video. See you next time.